Today we want to look at some of the trigonometric identities, and there's a whole bunch of these. This is just some of them, and we're only going to focus on these two, the reciprocal identities and the Pythagorean identities. But these are very helpful to you as you start working, not just in trig, but as you get into calculus. This is going to be something that is useful to you as you try to simplify equations. So the reciprocal identities are just given to us really by definition, that cosecant is the reciprocal of sine, secant the reciprocal of cosine, and cotangent the reciprocal of tangent. Now remember, another way to write this, since tangent is just sine over cosine, the reciprocal then, cotangent, is cosine over sine. So you'll see that written different ways, and you need to be able to recognize how you can manipulate equations using these very simple identities. Now, this last one, it matches. Cotangent goes with tangent. These two, however, I see more mistakes with secants and cosecants than probably any other, because it just feels like cosecant should go with cosine, and it does not. Cosecant is the reciprocal of sine, secant the reciprocal of cosine. So just don't get those mixed up, and it'll take some practice. I still have to think it through my head when I'm going through them just to make sure. But just recognize that's an issue. Now, the Pythagorean identities, the main one is this top one. Sine squared of theta plus cosine squared of theta is equal to 1. And these are just variations of it using those the identities that we just looked at. But when you think of Pythagorean, you think of Pythagorean theorem, which just says that if you've got a right triangle with the legs of the triangle A and B and the hypotenuse C, then A squared plus B squared equals C squared. So what does that have to do with our trigonometric identities? Well, the answer is everything. Because if you look at the unit circle, and if we were to draw a triangle in our unit circle, if you remember, because it's a unit circle, the distance here, or the length of my hypotenuse, is just 1. And by definition, this leg is sine, and this leg is cosine, and so if we're going to use the Pythagorean theorem, sine squared of x plus cosine squared of x is equal to 1, or in this case, theta. So a lot of times when you're playing around with identities, you're going to be asked to verify the identity, and usually you're given something that looks a little bit messy equal to something really pretty simple, and all they're asking you to do is use some of those identities to see if this side really does equal this side. And you almost always you want to play around with the more complicated side and see if you can simplify it to get it to equal the other side. So we're going to start off using the Pythagorean identities, and you're going to notice that none of them line up completely with this, but we do have this secant squared in both of them. But in this case, we've got secant squared theta minus 1. Well, here we have secant squared theta is equal to 1 plus tangent squared theta. But what would happen if we were to subtract this 1 to the other side? That would give us then secant squared minus 1 is equal to tangent squared. Well, that allows us to change this to a tangent squared. So this side then would become tangent squared over, and we're leaving the secant squared the same. Now remember, we're only working down this one side. Now all we're going to do with this next step is we're just going to rewrite this. So tangent squared times 1 over secant squared. So we've not really changed anything, we've just changed the way that it looks. Well, let's now change this then into just sines and cosines. All of these you can rewrite in sines and cosines. So we're going to use then these identities here that we started off with at the beginning. Tangent is just sine over cosine, so tangent squared is sine squared over cosine squared. Remember, secant is the reciprocal of cosine, so secant squared is the reciprocal of cosine squared. So we're just going to flip it, and this becomes then cosine squared. Well, now we've got sine squared cosine squared over cosine squared times 1, and these cosine squareds are going to cancel out, and we're left with just sine squared over 1, which is exactly what we were trying to do in the first place. So we have shown that this really does equal sine squared of theta. Now, you can make that complicated or you can simplify it. A lot of times there's not a right or wrong way to do this. So let's take the exact same equation that we started with, but let's go a little different direction. This time, rather than starting off using the Pythagorean identities, let's just change the way it looks mathematically and rewrite this fraction as secant squared over secant squared minus 1 over secant squared. Now again, we haven't changed anything, we haven't used any identities, we've just changed the way that it looks. Well, you'll notice right away, anything over itself is equal to 1, so secant squared over secant squared is equal to 1. And you'll notice 1 over secant squared, well, we know that secant is the reciprocal of cosine, so secant squared is the reciprocal of cosine squared. So this then equals 1 minus cosine squared. Well, that takes us to our Pythagorean identities here. We have a cosine squared. Now, this doesn't look identical, but what were to happen if we were to subtract a cosine squared from both sides? We get sine squared is equal to 1 minus cosine squared. Well, that's what we have here. So we've shown again that this is equal to sine squared. We just went a different direction with how we proved it. So the best thing to do with these is just play around with them, and you'll find that as you begin to recognize them, they actually become fun. But it's worth your time to learn the identities until you just start seeing them naturally in the equations that you're working. Most of the time when you're working with these, unless it's a section on trig identities, you're not going to have something like this in the side saying, hey, look for these identities. But you'll start recognizing them quicker than you think. But you're going to have to practice them. It's why you have sections on this. It feels like busy work, and it really is busy work because it's trying to get into your mind what they look like and being able to recognize when you can start altering the equation itself to make it look different and easier to work. Now, if you like logic puzzles, then these trig identities really are your friend, because that's really all they are. They're just logic puzzles. You're taking something that's complicated and you just keep simplifying it until it's something simple. And you can go online and just look for trig identity problems, or if you're just sitting there and you've got nothing to do, and I know a lot of times you're just going to go on social media and just swipe. Rather than that, just create your own problems. Start with something simple. Maybe pick one of the identities just the way that it's written. Maybe start with sine squared plus cosine squared is equal to 1, and then just start manipulating it to make it more and more complicated. And once you get it pretty complicated, then set it aside and maybe do a different one, and then come back later, start with the complicated side and start working it down to something simple. But play around with them. They really can be fun if you like those logic type puzzles. Okay. Thanks for watching. Please like and subscribe. If this is helpful to you, pass this information on to others that it might be helpful to. As we're getting started with this channel, it is helpful to me if you send me messages on some of the things that you'd like to see so that I know which videos to add first. So again, thanks for watching.